You have probably heard of conic sections. And if you have, here is a picture of what was being referred to most likely. Notice these little yellow curves here, okay? And notice how these curves are formed. These curves are formed by taking a plane and cutting down through a cone. See, and they form this little yellow curve. Here we have a parabola, here a circle, an ellipse, hyperbola. These are conic sections. Now, and of course, you get different conic sections depending on the angle of your plane. What we're going to focus on here is the parabola, right here. So let's look at this. Here's a picture of a parabola. Now, you've encountered parabolas before. Back when you studied polynomials, you studied parabolas and you learned to find roots, y-intercept, vertex, that sort of thing. So you studied parabolas before, but now we're going to be concerned with different characteristics of the parabolas. Now, first of all, I need to define for you what we mean when we say a parabola. What makes a parabola a parabola? It's not just the shape of it. It's very specific what makes something a parabola. A parabola all parabolas have what's called a focus. Now that focus is a distance up from the vertex, and I'm going to call this distance P. So this point, and for simplicity's sake, I'm saying I'm using a parabola that has a vertex of 0, 0. But this particular focus here, I'm going to say is P units up from the vertex. So we have the vertex to be 0, 0, and the focus to be 0P. Now also, something else that a parabola has, it has a directrix that's also P units down from the vertex. So here is the directrix. We might call that y equals negative P. So we have a focus and we have a directrix. All parabolas have these, and it's part of the definition. Now, let's suppose that we go from this focus up to any point on the parabola, like this. And then from that point, we go down to the directrix. The distance from the focus to that point and the distance from that point down to the directrix, they're the same. They're the same distances. Whenever you have that situation, in other words, whenever you have a situation where you have all these points and they all have this property, notice, here's what the parabola is. It's all of the points that are equal distant from a vertex and to a directrix. Okay, so you've got not the vertex, the focus. I may have said the focus. They're equal distance from the focus and to the directrix. In other words, D1 and D2 are the same for any of these xy's. Well, all of these xy's, that's what make up the parabola. It's the union of all those. There are infinitely many. All these xy's, they're the same distance from the focus as they are to the directrix. Each point has that property. That makes a parabola. So when we talk about a parabola, we're very specific. That. It's the union of all those points that have that property. Now, let's see if we can come up with a formula then for a parabola. Notice that I said that D1 and D2 are the same. So let's look at, let's use the distance formula and calculate the distance from xy to 0p. Well, it's going to be the difference of the x's, x minus 0 squared, plus the difference of the y's, y minus p squared. Yeah, that's that D1 right there. Now what about D2? Well, the x's are the same. Notice I'm just going straight up and down. Doesn't look like, my line might look a little crooked there, but it's supposed to be straight up and down. So this is going to be x minus x squared, difference of the x's, plus a difference of the y's. Y minus a negative p, right? Because this is the point x negative p right here. Now, let me just square both sides to get rid of that radical. Okay, I just square both sides. That's all I did now. And by the way, I just dropped this x minus x. That's just 0. Now, let me multiply everything out here. Okay, so I've got x squared, and then over here I've got x squared, y squared minus 2 py plus p squared. Then over here, I multiply this out. Notice this is y plus p squared. And notice some things cancel. Look at these p squares. They cancel. These y squareds, they cancel. And what I'm left with is x squared minus 2py equals 2py. Bring that negative 2py over, and I have this. Now, notice what I have here. I have a formula for a parabola, just a general form for the parabola. And dig this. This 4 is always going to be there. It's the coefficient of this p. And remember, p is the distance from the vertex up to the focus and from the vertex to the directrix. Okay, so we've got a focus that's 0p and a directrix y equals negative p. Now let's look at an example. Let's suppose that we've got this formula for a parabola, and we want to find the vertex. Well, the vertex is 0, 0. And as you can see here, this is just your base. You can think of this kind of like a parent function. This function has not been shifted to the left, right, up, and down. It's just the vertex at 0, 0. Now, the focus is going to be 0, 2. Notice all I did was I added 2 to the y-coordinate here because the focus goes up from the vertex for this particular one. And then the directrix, I subtract 2 from the y. So y equals negative 2. So these are the things that we're going to be interested in. We want to find the vertex, the focus, and the directrix. Now let's look at another one. Here's one. X squared equals 16y. Now you notice this doesn't have 4 times anything. It has 16. Well, I could write that, though, as 4 times 4. So by rewriting it, now I have this form, and I can immediately say, okay, I know what the vertex is. Now, let's see here. P is 4. I see it right here. So what I need to do is I need to add 4 to the y and get the focus. Subtract 4 and get the directrix. There we have it. Okay, let's look at another one. X squared equals y. Okay, now I don't have anything in front of the y. So look, I want to get the vertex, I want to get the focus, I want to get the directrix. Well, the focus is, the vertex is going to be easy for us. It's just 0, 0. There hasn't been any vertical horizontal shifts. It's just x squared and y still. However, if I want to find the focus and the directrix, I'm going to need to do some fancy footwork here. I need a 4 in front of this y, and I have none. So what I'm going to do is I'm going to do something that's just fine. It's legal. Just multiply by 1. Multiply by 4 over 4. See, I can do that. That's just like multiplying by 1. And the reason I do that is because now I can rearrange. I can pull one of those 4s out front and then have 1/4 inside. See, look at this. 4 over 4 or 4 times 1/4 is the same. Now I can see, oh, 1/4, that's the P. That's the P right there. So I have a vertex, which is 0, 0. I have a focus, which is 0, 1/4. I just added 1/4 to it. And y equals negative 1/4. That is my directrix. Okay, let's look at this one. X squared equals 5y. Now, what I need to do the same trick. I don't see a 4 there, so bang, there's a 4. I just multiply by 4 over 4 and pull one of those 4s under the 5. There we go. That's nice. Now we can see what the P is. Now we can see how far from the vertex do we need to go to get the focus, and how far do we need to go to get the directrix. So we got the vertex, which is 0, 0, the focus, which is 0, 5/4, and y equals negative 5/4 for the directrix. Okay, now let's look at this. Kind of summarize. X squared equals negative 4py. So actually, this is something new. I'm not summarizing yet. I've got negative 4 here. So what happens when I have a negative 4? Okay, now let's see how we would deal with something like this. I've got that negative in there. It's not just x squared equals 4py, it's x squared equals negative 4py. So what does that do? Well, it turns the graph upside down, like this one. And you notice what happened here. Our focus is now below the vertex, and our directrix is now above the vertex. So we need to adjust our approach just a little bit, because we're still going to use this p in the same way, but we have to be careful. So let's look at this. Let's look at this example. X squared equals negative 4 times 2y. Now, notice the p is still the same. It's 2. But we recognize that this is an upside-down parabola. To get to our vertex is going to be the same, 0, 0. However, to get to the focus, we're going to need to subtract 2. See, if we're right here, we're going to need to subtract 2 to get down here. Can you dig that? See that? Instead of adding 2. So we're going backwards from what we did before. And then to get to the directrix, we add 2. So if it's minus, it's going to, we have to adjust the way we're thinking about it. Okay? So what I'm saying is, you have to be careful with each problem and know, okay, I don't want to just give you a formula, do this every time. It's enough to know that I'm going to take this p and I'm either going to add it or subtract it. But I need to know the orientation of the parabola. Is it opening up? Is it opening down? Because that dictates to me what I'm going to do. Do I add p or subtract p to get the focus? Do I add or subtract to get the directrix? And so forth. Now let's look at this one. Here's another one. Okay, now we know this is an upside down parabola. And the problem with this one, in addition to just having the negative, is we don't have 4 times anything here. Well, I need a 4 times something, right? So I do my old trick. I multiply by 4 over 4. And when I do that, I pull one of the 4's in and keep one of the 4's out, and now I've got this. 4 times 3 is 12. So now I can see what the p is right here. Okay? So here I go. Now, I realize this is a parabola opening upside down. I've got my vertex, 0, 0, no worries there. But now what I want to do is I want to find the focus. I'm going to need to subtract from the vertex to get the focus because it's upside down. See? So I subtract. I take 5/12 from 0. Now, as far as the directrix goes, I add 5/12 to 0. So notice, I subtract 5/12, add 5/12, and you can see. So it might be a good idea whenever you're working through these, if you can, go ahead and sketch the graph. And if the parabola is opening up, you're going to add to get the focus. If it's opening down, you're going to subtract to get the focus. Yeah. Okay, now, here's what we have. We have parabolas opening up. We have parabolas opening down. And in both cases, we have the directrix and the focus that we're going to have to find. Now, these are the two broad categories. You can think of these like parent functions. Notice over here, we're going to add, if it's opening up, we add to get the focus, subtract to get the directrix. Over here, if it's opening down, if it's negative, we subtract to get the focus, we add to get the directrix. Now, let's spice it up a little bit because both of those parent functions had the vertex at 0, 0. Now, let's suppose we put some shifts in there. Like here, we've got a little horizontal shift. Now, remember, our vertex was normally at 0, 0. That's just when we had x squared and then a y. But this is no longer 0, 0 because what's happened is we've got a number being subtracted from the x inside the parentheses being squared. Well, remember, that's an indication that you have a horizontal shift. In fact, this is a horizontal shift to the right. So what we have is, now notice, nothing's happened to the y. However, we've had a shift to the right. Now, so remember, you're going to get the x-coordinate of your vertex from the parentheses with the x, only it's going to be the opposite. You might recall that from back when you studied transformations before. Okay, so now we've got the vertex. Now, this is just a parabola opening up. So if we want to get the, and by the way, this x equals 3, this is the axis of symmetry. We've been, in the examples we've looked at before, the axis of symmetry has always been, the y-axis, x equals 0. But since this has been shifted over 3 units, x equals 3 is the axis of symmetry. And x equals 3, the axis of symmetry is the axis about which the parabola is symmetric. In other words, if you fold the parabola along the axis of symmetry, it should lay directly on top of itself. It's the line that cuts right up through, and in this case, with the parabola opening up or down, it's just the line y equals the x-coordinate of the vertex. So here is the axis of symmetry. Okay? Now we also have the focus. Notice the focus, we're just going to add 2 to the y-coordinate. There's the focus. And for the directrix, we subtract 2. This vertex was at 3, 0. If we subtract 2 from the y, we get y equals -2. Now here's what the graph looks like. And notice, here is the axis of symmetry. See, the axis of symmetry, before we didn't pay much attention to it because it was just the y-axis. But now we're shifted over, and now our axis of symmetry is over here. But remember, it's the y equals the x-coordinate of the vertex. Okay, let's try this one. Now notice, it's not something in there with the x. There's not a horizontal shift. Now we have a vertical shift. And here's the deal. It's inside here with the parentheses. What we're going to do then is we're going to talk about the vertex being HK, being what's in the parentheses with the x, only the opposite. What's in the parentheses with the y, only the opposite. Now, there's nothing in here with the parentheses. Okay, now let's look at this one. This one, notice we don't have a horizontal shift here. It's just x squared. However, over here with the y, we do have a vertical shift. This is y minus 3. So our vertex, the x hadn't changed. However, the y has. So we've got a y minus 3. That means we have a shift up 3 units. Because notice it's in the parentheses, y minus 3, so it's a vertical shift up 3 units. If that had been a y plus 3, it would be a vertical shift down 3 units. But here we go. We have, this is our vertex. Now, this is a parabola that opens up just like before. It has the axis of symmetry to be x equals 0. Notice there's, that's the x-coordinate of the vertex. As far as our focus goes, we're just going to add 2 onto this 3. See, there we go. 3 plus 2 is 5. And then we subtract 2, 3 minus 2 to get our directrix. And here's what that graph looks like. Notice there's our focus, here's our directrix, and here's our vertex. Okay, now let's look at this one. Now, let's put them together. We've got horizontal shifts, and we've got a horizontal shift and a vertical shift. See, look at this. Horizontal shift and a vertical shift. So now we want to get the vertex. And here's the deal. We're going to get 2 things for the vertex, an x-coordinate and a y-coordinate. The x-coordinate comes from the parentheses with the x, only the opposite. The y-coordinate comes from the parentheses with the y, only the opposite. So we get 1, -5. That's our vertex right there. Now, this graph opens upward. Okay, we've got our axis of symmetry to be x equals 1. And we're going to now find our focus. I've got the -5. I'm going to add 2 to it to get the focus. So that's going to be -3. See, -5 plus 2 is -3. Now, I want to get the directrix, so I'm going to subtract from -5. So I get y equals -7, and here's what that graph looks like. Okay, and you can see the focus, the directrix, and the vertex here. Okay. Okay, so here's the situation. This is just the general form. We've got h minus h squared equals 4p y minus k. The focus, the vertex is going to be hk. X comes from the parentheses with the x, only opposite. Same for the y, from the parentheses with the y, only the opposite. The axis of symmetry is x equals h, always. For if it's in this form, if it's the x squared. We'll look at other cases later, or another case later. Now, as far as the focus goes, I'm going to add p to the k. See? And then the directrix, I'm going to subtract p from the k. And it will look something like this. Now, if we have the negative in front, see? So I have the negative. Still going to have the same vertex, the same axis of symmetry. However, to get the focus, we're not going to add to the k, we're going to subtract the p. To get the directrix, we're going to add the p, and it's going to look something like this. So, this is just the general form right here of these parabolas that either open up or open down, and this is the process for getting the vertex, axis of symmetry, focus, and the directrix.